next concept in Python, which are operators. So as the name states, you can basically perform different sort of operations on the data or on the variables with the help of these operators. So you've got arithmetic operators, relational operators, and logical operators. So we'll start with arithmetic operators. So let's head on to Jupyter Notebook. So I'll go ahead and create two new variables over here. I'll name one variable to be A, and I'm storing 10 inside this. I'll create another variable with the name B, and I'll store the value 20 inside this. So I've got two variables. A has the value 10 and B has the value 20. Now, arithmetic operators, as the name states, you can basically perform arithmetic or mathematical operations on top of the data. Now, so these operators are basically, you have plus, minus, multiplication, and division. So I'll just type it down over here. You've got plus, you've got minus, then you've got multiplication, which you can do with the star operator, and then you can do division, which you can do with this /. Now, there is actually something known as comments in Python. So if you don't want your code to be executed by your compiler or your interpreter, all you have to do is use this hash symbol. So I'll type in hash. Now, if you just put in hash before whatever you write in front, then it will be taken as a comment, or it will not be executed by your compiler or your interpreter, right? So we can use these comments to basically add some sort of title, or just to let us know what are we actually doing with this code written. So I'll just change this to arithmetic operators over here because we are working with arithmetic operators. So I'll type in arithmetic operators. Now we've got our two variables ready. So I'll go ahead and start with our first arithmetic operator, which is addition. So to add two numbers, I would have to use the plus operator, and I'll just type in A plus B. And as you see, we've got 30 because 10 is stored in A, 20 is stored in B, and when you do 10 plus 20, you get a value of 30. Now let me subtract B from A. So I'll do A minus B. So we get a value of minus 10. So when you subtract 20 from 10, you get a value of minus 10. You have to understand two things over here. A minus B is actually different from B minus A, right? So I'll type in B minus A over here. So we get a value of 10, right? So over here, B comes first and then A comes second. So 20 minus 10 is 10, but 10 minus 20 is minus 20. So this was subtraction. Now we'll head on to the third type of arithmetic operator, which is multiplication. So I'll type in A star B or A multiplication B. So when you do 10 into 20, you get a value of 200. Now, isn't this quite simple? So we're done with addition, we're done with subtraction, we're done with multiplication. Now we'll head on to the fourth part, which is division. So A divided by B. So to divide two variables, you will use the /. Now I'll click on run. So 10 upon 20 will give you a value of 0.5. So these were the arithmetic operators. Now, isn't this very simple? Right, so we're done with arithmetic operators. Now we'll head on to the next set of operators, which are relational operators. So again, I'll add in a comment and I'll type in relational operators over here. And our relational operators would basically be the greater than symbol, the less than symbol, then you've got double equal to operator, and then you've got the not equal to operator. Let's understand each of these one by one. So again, we'll take the same set of values. We've got A and B, 10 is stored in A and 20 is stored in B. Now, I want to check if A is greater than B, or the value which is stored in A is greater than the value which is stored in B. So I'll type in A, and then I'll use the greater than symbol, and then I'll type in B. Now let me hit run. So I get a false value. This is because 10 is not greater than 20. Right? Since 10 is not greater than 20, I get a false value. Now, similarly, I'll check if A is less than B. So I'll use the less than operator and then I'll type in B over here. Now I'll click on run. So as you see, I get a true value because 10 is less than 20. Now I'll check if the values which are present in A and B are actually equal. So A, and now I'll put in two equal to operators. So when you have two equal to operators followed in sequence, that is when you are checking if two values are equal, right? So with the help of this operator, I am checking if the operand on the left side of it and the operand on the right side of it are equal to each other. Again, I'll click on run. So I get a false value because 10 is not equal to 20. Now I'll use the not equal to operator. So A is not equal to B. I'll click on run. So as you see, I get a true value because A is not equal to 20. Now let me change these values over here. So let's say I'll type in A is equal to 100 and B is equal to 100. I'll hit run. Now again, I'll use the double equal to operator and I'm checking if A is equal to B. So as you see, I get a true value because 100 is equal to 100. So this is how you can work with the relational operators. So summing it up, you got the less than operator, greater than operator, less than or equal to, and then you got the not equal to operator. Alright. Now we'll head on to the final set of operators, which are logical operators. So again, I'll add in a comment, I'll add the hash symbol, and then I'll type in logical operators. So your logical operators are your AND operator or operator. So let me start with the AND operator. So the AND operator will give you a true result when both the operands are true. On the other hand, if any one of the operand or both the operands are false, then you'll get a false result. So that is how AND operator works. Now let me store the value true in A and I'll store the value false in B. So we've got our variables ready. Now I'll use the AND operator with respect to these both variables. So I'll start off by typing A and B. So true and false will give us a false value because one of the operand is false. Now similarly, I'll type in B and A. So when I type in B and A, I'll again get a false value because one of the operand is false. Now I will type in B and B. So B and B, guess what? Well, I can get a false value because both of them are false. Now I'll type A and A, and this is when we'll get a true value because both of the operands are true. And as I've already told you, when both of the operands are true, that is when we'll get a true value with respect to the AND operator. So now we'll head on to the OR operator. So OR operator is denoted by this pipe symbol over here. So this pipe operator would give us a true result when either of the operands is true or both of the operands are true. So we'll get a false value with respect to the OR operator only when both the operands are false. So again, we've got A and B over here. So I'll just type in A or B. I'll click on run. So as the value of A is equal to true, but since B is equal to false, but then again, we have at least one operand whose value is equal to true. So that is why we have a true value over here. Now, similarly, I will type in B or A. So when I type in B or A, I again get a true value because A is true. Now I'll type in A or A. Well, obviously we get a true value because both of the operands are true. Now I'll finally type in B or B. So when I type in B or B, I get a false value because both of the operands are false. So summing up, with respect to the AND operator, we get a true value only when both of the operands are true. And when it comes to the OR operator, we get a false value only when both of the operands are false. So this brings us to the end of this operators session. So now we'll head on to Python tokens. So a Python token is basically the smallest meaningful component in a program. And in a programming language, or basically in Python programming, we've got these 4 tokens. So we've got keywords, identifiers, literals, and operators. So we've already understood what exactly are operators. Now let's understand what are keywords, identifiers, and literals. So let's start off with keywords. So as it is stated over here, keywords are special reserved words. Now these special reserved words will give a meaningful information to the compiler or the interpreter. So as you see, you've got all of these keywords over here: if, or, not, with, is, class, def, and so on. So when you type in this keyword, the Python interpreter or the compiler will treat this as a special reserved word, and it knows that it performs a special function. Now, another thing to keep in mind is you cannot have a variable name or a function name or a class name to be a keyword because this will cause an error. So as I've already told you, keywords are special reserved words, and obviously you can't use these special reserved words as the names of variables. So let me just go to Jupyter Notebook and show you some of these keywords. So I'll just type in if over here. So as you see, this has been highlighted in green. So in Jupyter Notebook, all of the keywords are highlighted in green. I'll click on run. So as you see, there is invalid syntax because if tells the Python interpreter that there has to be something followed after if. Similarly, if I type in, let's say, true, true again is a keyword which is reserved, right? Now I'll follow it with def. So as you see over here, this would actually create a function, but then again, this has to be followed with a function name. So Python interpreter is treating this as a special keyword and it has to be followed with something else. So the next set of tokens are identifiers. So identifiers are names used for variables, functions, or objects. So as in real life, if you have to call someone, people have names, don't they? Let's say you have your best friend whose name is Lisa, right? So Lisa is actually her identifier. So Lisa is being identified by her name. So similarly, if we have to identify something in the programming world, we would have names associated with them. So obviously the data which we've got are variables, functions, and objects. And if we have to identify these variables, functions, and objects, then we have to give them some sort of name. And these are the rules which you'd have to follow when giving a name to these variables. So you cannot have any special characters in the name of the variable, right? So except underscore, you cannot have any other special characters. Now, it is also important to keep in mind that these identifiers are case sensitive. So let's say if you given the name as Lisa where L is capital, and also then you have another identifier where L is small. So both of these would be different. Now, similarly, you've got another rule over here. So the name of a variable, function, or an object, it cannot start with a digit. It can only start with a character or an underscore. So let's just check some of these rules in Jupyter Notebook. So let me create a variable with the name, let's say, I'll give it Lisa, where L is capital, and I will store I am Lisa. Now I will have another variable with the name Lisa where L is not capital, and I'll store, let's say, I am L. Now let me just print Lisa over here where L is capital, so I get the first one. Now I'll print Lisa over here where L is small, so I get the second one. So as you see, Python interpreter treats both of these variables as different because these variables are case sensitive. So we are done with identifiers. Now we'll go ahead to Python literals. So Python literals are extremely easy. So they are nothing but constants in Python. So they are constants which do not change. So basically you have numeric literals, you've got string literals, boolean literals, and so on. So whatever values are stored in the variables, those values are nothing but literals. Now let's say if you have a variable with the name A1 and you store a value Sparta inside this. So over here A1 would be the variable and you are storing a string literal inside this, and that string literal is Sparta. Similarly, now what I'll do is the variable name is A, but I'll be storing a numeric literal inside us, and the value of the numeric literal is 123. After this, I'll again give in a variable with the name A1 and I'll store a boolean literal. So the value of boolean literal would be true, right? So as you see over here, literals are nothing but constants and these are values which go inside variables. So Python strings are a sequence of characters enclosed within single quotes, double quotes, or triple quotes. We've got these three examples over here. Let's try out all of these three examples in Jupyter Notebook. So I'll start off by creating my first string. So I'll name the variable as S1 and I will have single quotes over here, and the value which I'm storing inside this would be hello world. let me print S1 over here. So as we see, the result is hello world. Now let me also check the type of it. So type of S1, and as we see, this is a string. Now I will go ahead and store another string value inside this. So now instead of single quotes, I am putting in double quotes. So this will be, this is Sparta. Now let me again print the value of S1. So as we see, the value has been changed from hello world to this is Sparta. Now again, I'll check the type. So type of S1. So as we see, it's still a string. So single quotes or double quotes, it doesn't really matter. It's a string. Now I'll go ahead and create a multi-line string. So I will store, I'll just give in 3 quotes over here, and I will type this is a multi-line, and I will type in string. I'll click on run. Now let me put in S1 over here. So as we see, this is a multi-line string. So as we see, so this \n, this basically is for a new line. So this tells us this is a multi-line string. We've got this is a multi-line in the first line, and then we've got string in the second line. So this is how you can work with strings in Python. Now we will go ahead and see how can we extract individual characters from a string. So over here, we've got a string with the name my string. So this is basically the variable name, and the value is my name is John. Now you have to understand that the indexing in Python, it starts with 0 and not 1. So over here, the first index value is 0. So at index 0, M is stored. At index 1, Y is stored. At index 2, it is space, right? So the indexing starts from 0. And if you have to extract the first character from this, you just have to give in the name of the string, and then you'll give in the parentheses, which are basically these square brackets, and inside that you will give in the index number, which is 0. So since you want to extract the first character, you're giving in 0. Similarly, if you want to extract the last character from the string, you will give in -1, right? So n is the last character and you're extracting it. Let's perform these operations in Jupyter Notebook. So I will create a new string with the name my string over here, and I'll type my name is John. Now I want to extract the first character from this. So I'll just give in the name of the string, which is my string. After this, I'd have to give in parenthesis, and inside this, I'll give in the index number, which is equal to 0. So as you see, I have extracted the first character. Now similarly, if I want to extract the last character from this, I'd have to give in -1. So instead of 0, I'll just put in -1 over there. Now I'll click on run. So as you see, I have extracted n from this. Now let's say if I want to extract this A over here, so this is presented 0, 1, 2, 3, 4. So this character A is presented index number 4. So again, I'll type in my string and I will put in the index number, which is 4. So I have successfully extracted this. Now let's say if I want to extract a sequence of characters. So I want to extract the substring name from this entire string. So this will be 0, 1, 2, 3. So n starts at 3 and will go on from 3, 4, 5, 6. So I'd have to give in 7 as well, because the first element would be inclusive, but the last element would be exclusive when we are indexing a string. So I will type in my string over here, and so this is 1, 0, 1, 2, 3. I'll type in 3 and then I'll give in a 7 over here. So I have successfully extracted this name. Now let's see what happens instead of 7 if I actually give in a 6. So I'll just click on run over here. So we see that we only get NAM. So this will, if it is only 6, then this means that we are taking only 3, 4 and 5. So this is 3, this is 4 and this is 5, right? So that is why we'd have to give in 7 as well. So when we give in 7, this will take the index values 3, 4, 5 and 6. So this is how we can extract different substrings. Now let's say similarly, if I want to extract John from this. So let's see, where does John start? So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So I'll just put in 11 over here, and this will go to 12, 13, 14, and let me just put in 15 over here. So I have successfully extracted the substring John from this entire string. So this is how we can extract individual characters from a string. Now let's work with some string functions. So these are the three basic string functions which we have. So let's say if I want to find out the length of a string, then we can use this len function. Then if we want to convert our string to lowercase, then I can use this toLower function. Similarly, if I want to convert the string to an uppercase, then I have this upper method. So let's go ahead and work with these three functions. So let me just actually cut this off. Let me have a clean notebook first. So I'll type in my string, which is my name is John. So as you see, M is capital and J is capital. So now I want to start off by checking the length of the string. So I'll use this len method, and inside this I will pass in the myString variable. So as you see, the length of this is 15. Now I want to convert this entire string to lowercase. So all I have to do is, given the name of the string, which is myString, I'll use the dot operator, and I will invoke the upper method using this dot operator. So I will click on run. So as you see, I have converted this into uppercase. Now similarly, if I want to convert this into a lowercase, first I'd have to give in the name of the string, which is myString, and then I will give in lower over here. So as we see over here, this entire thing is converted into lowercase. So these are the three basic functions. So with the help of len, we can find out the length of the string. With the help of this upper method, we can convert this entire string into uppercase. So as you see over here, all the characters have been converted to uppercase. And similarly, with the help of this lower method, we were able to convert this entire string into lowercase. Now we'll look at two more functions. So if we want to replace a substring, so let's say over here, initially the string was my name is John, and I wanted to replace Y with A. So we can use this replace method, right? So instead of my name is John, the string is now changed to my name is John, right? Well, the string has a bit of swag associated with it, isn't that? Now, if you want to check the number of occurrences of a substring in a given string, so over here, as you see, we've got hello, hello world. Now, if I want to check the number of occurrences of hello, I can use the count method, and inside this, I will just pass in the substring. So we see that hello occurs 2 times. So let's work with both of these methods. So first, let's work with the replace method. So we've got the myString over here already. So I'll type in myString.replace, and I want to replace, let's say, name with something. So I want to replace my name with, let's change this to age actually. Well, this is actually strange, but then again, well, there's a guy whose age is John, isn't it? Now, similarly, let's say if I want to replace John with something, so I'll just write the first parameter, which is John, and then I'll give in the second parameter, which is Sam. So initially the guy's name was John, and I am changing the name to Sam. So you have to keep this in mind. So this takes in 2 parameters. The first parameter is basically the substring which you want to replace, and the second parameter is the substring which you want to replace the original substring with. So this is how the replace method works. Now let's go ahead and work with the count method. So let me create a new string over here first. So I'll type in S1, and let me just type in some random sentence over here. So I'll type in hello world, this is Sparta. Hello world is hello. Right, so we've got our string over here ready. So S1 dot count, and let me give in a substring over here. So let's say I want to see how many times the substring hello occurs in this sentence. So see that this occurs 3 times. So let's just verify this. We've got hello over here once, twice, and thrice. So this is absolutely right. Now Let's again check how many times the substring world occurs. So I'll type in world inside this. And we see that the substring world occurs 2 times. So we've got world over here once and we've got world over here twice. So these are the 2 different methods with the string function. Right, now we've got 2 more functions. Let's say if I want to get the index of a substring. So in this sentence over here, we've got this entire string, which is this is Sparta. Now, if I want to get the index from where a substring starts, right? So I want to get the index of this particular substring, right? Which is Sparta. So let's just check. 0, 1, 2, 3, 4, 5, 6, 7, 8. So as you see, S starts from index number 8. And with the help of this find method, we were able to get that particular index. Now, similarly, if I want to split a string into different parts, this is when I can use the split method. So over here, I am creating a sentence. So the sentence says, I like apples, mangoes, and bananas. And I want to split this sentence into 3 parts on the basis of the split criteria, which is the comma. So wherever the comma is there, it will split that into one particular substring, right? So whatever is there before this comma, that is taken as one string. Now after this, it is one substring, and then again after this, it is another substring. So let's also work with this find method and the split method. So let me go ahead and create a string first. Now let me type in this as Sparta. I'll give in double quotes over here. So I have created the string. Now I want to know where does P start over here, the index of P. And since there's only one P over here, that will be quite easier. So I'll just type in s1 dot find and I'll type in P. So the index seems to be at number 9. So let's just verify this. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we see that the character P is at index number 9. So it's easy, isn't it? Now we'll go ahead and also work with the split method. So for this, let's create another string. So again, inside S1, I'll add something else. So I'll type in the students' names are John, Sam, Matt, Julia. So we've got the string ready over here. Now I'll type in s1 dot split and I am splitting this with respect to comma, right? So we've got this separated. So the first part is the students' names are John, and then we've got Sam, then we've got Matt, then we've got Julia, right? So all of this has been separated with respect to comma.